Good evening, everyone. Am I audible?
Yes, ma'am.
And I have shared my screen. Kindly acknowledge this. My screen is visible.
Yes, ma'am. It's visible.
Yeah. Thank you for the response, people. So, in this session, we'll be discussing the week 11. That is nothing but depth first search. What is depth first search, people?
So in a given graph, so DFS starts from a node and goes on till it reaches the very depth of that graph. So it
Yes, it goes.
doesn't go layer by layer, rather it goes on stacks.
Yes. Okay, others, any idea about depth first search? All right, people, I'll tell you then. So, depth first search in the sense of, let's say I'm taking the tree A here. So from A, let's say it will go deeper to B. From B, though there is something like this also, it will try to go deeper and deeper. Okay. So let us, it explores as far as possible. So it will keep exploring through the end and then it will stop. Either it can be in this way or else it can be in this way. It will never do the overcross. Like say uh, A, D and C are connected. So first it will just complete through one way, then it will come to the other path. So that is what is said to be the depth first search. Okay. And here we use the concept as backtracking. What does mean by backtracking?
So we start from some vertex I, let's say, and visit an unexplored neighbor, and then we suspend that the exploration of I, and then just explore J instead, and we suspend the exploration of I, and again backtrack to the nearest suspended vertex that still has an unexplored neighbor, sort of.
Yes, correct. So then generally DFS is used to find the all possible path. Okay, all possible path. So for that only we can use the DFS. So if there is a cycle or not, so for those things, that is to explore all the possible paths, we'll use this depth first search. Okay, so backtracking in the sense of, let's say from A it is connected to B, and from B it is connected to C, and C to D, D to F, something like this. So it will travel through all the paths. After F, let's say D is also connected with E, and C is also connected with X and Y, and B is also connected with Z, something like this. And A is connected with TUV, something like this. So as of now, I have chosen a path as A to B, B to C, C to D, D to F. So after reaching F, is there any other points to reach there?
No.
So what it has to do is it will backtrack. That is, it will go to the previous step, just previous, not the above one. It will not go to A or B, nothing like that. It will just go above it, like its previous vertex. So from previous vertex, it will check for the unvisited vertices. So here E is unvisited. So it will visit E. So after visiting E, is there any other vertices are there?
No,
No,
you
right?
can backtrack to D, right?
Yes, again it will backtrack to D, and from D it will check for the unvisited nodes. So again it is backtracking to C. C, is there any other unvisited nodes? Yes, it will visit X, then backtrack to C, check for any other unvisited node. Y is there, visited. Then check for any other unvisited node. Is there any other unvisited nodes are there?
Yes, it will go to B.
Yeah, it is not, so it will go to B. So from B, Z will be visited, backtrack, and then again B to A, it will backtrack. From A, it will traverse to T, backtrack to A. Unvisited node U is there, and then backtrack to A. Then V, again backtrack to A, something like this. So this is how it will do the backtracking process. Is it clear, people?
Yes.
Okay, let me tell you a very simple example for backtracking. So I think in your childhood or even in some children magazines, you will have seen this, right? There is some animal is here and its house or its food will be here. It's like a maze game. So there will be a multiple paths from here to, it will just lead to some path in between. And then there will be a path like this. And there will be something like this also. And then there is one path which will lead to this. Have you ever seen this, people? Yes, do you all remember this?
Yes.
Yeah. So here what I can do is, let's say from this one, I'm just taking the path like this. Is it leading to the destination? No. So what I'll do, I'll just come to the starting point. Then from there, I'm trying to use the another path. Is it leading to the destination? No, it's not leading to the proper destination. So what I'll do, I'll try to do the backtrack and I'll go to the starting point again and I'll check with the other places, right? Isn't it, people?
Yes.
Yes.
Yeah, let's say instead of this path, it is just like this. So there is some cut also. Now what it will do? Will it go to the starting point or it will come to this point? In this case, it will just start from here. It has reached this point. From this point, there are two paths. Initially, I have chosen this path, which is not leading to the destination. So what I'll do, I'll come to this step. Then from here, I'll just go and I'll check. Is there a path? Imagine there is a path here. Then this will lead to a destination, right?
Yes.
So this is what is backtracking. Initially, I'm choosing one path and I'm trying to reach the destination. Not possible. I'm not going to the starting point. In between, there is a point, right? So from there, I'll try to check. If this is also not possible, I'll go to the previous step. Something like this. So this is what is said to be a backtracking. Is it clear, people?
Yes.
You can take a normal example like from your place. Let's say you want to go to some college or a workplace. So from your home to a workplace, is there only one path is there? Of course,
No.
no, right? There will be multiple paths. So initially, let's say it is the first day you are going, or you are just going on some random travel, something like that. So on that time, will you use the straight path which you know, or you'll try to explore the other ways?
We'll explore the other ways, right?
Yeah, because we want to know whether that is the shortest path or is there any other shortest path we can reach, right? So similarly, let's say there is a path one, path two, path three, something like this. Now, when I'm going to path, this is my destination. This is the destination point, but it is like a like what you can say. It's a here there is a block. After this, the road is not there. Something like that. So in that case, I'll try to go through this path. Is it leading to a correct destination? I'll check. No. So let's say there are, of course, a street will not be like this, right? So there will be like some multiple paths will be there. Like it will go to this street, and there will be one more path as well, and then like this. And let's say there is a path like this also, something like this. Of course, this is how the road looks, right? So let's say what I'll do is, as of now, I have taken a straight path. It is not working out. So what I'll do, I'll go to this way. From here, is it possible to reach the destination? I'll check. If not, what I'll try to do, I'll come back to this position, right?
Yes.
Yes. So from there, I'll go and try to check through this path. If this is possible, it's fine. Otherwise, what I'll try to do, again, I'll come to this path. And from there, is there any possibilities there or not? I'll check. The straight road will be there, or there can be this cut, or there can be one more cut here, something like that. I'll try to go and explore through this path. Is it reaching the destination? No. So come back here and try to go forward. And I'll try to check through this path. If that is also not possible, I'll go straight. That is how we go, right?
Yes.
Yes, ma'am.
Yeah, so this you can take as example of a backtracking. So I'm going through some path. If that is not leading to a destination, I'll go to the previous step. From there, is there is any other nodes or I mean, is there any other path which is unvisited? I'll try to visit that path. I'll try to find a way for that. If that is not possible, again move back to the previous one. I'll try to find the other ways. So this is how the backtracking works. Is it clear, people?
Yes, ma'am.
To everyone?
Yes.
Great. So here, that's why they have said as a recursive procedure. What does mean by recursive? Or what is recursion?
You go through you repeat the same procedure every time.
Yes. Like recursion in the sense of calling the same function again and again. Do you remember? Do you have any idea like what is recursion and all?
We know recursive functions, right? So
Recursive
yeah,
function
that's
till we get the answer. Like repeating same function,
Yes.
calling same function again like, till we get the answer.
Mm-mm-mm. Okay, fine. So, recursive in function in the sense of, let's say there is some function here. So inside the function, we'll call one more function. Let's say x is here. So using x minus 1, I'm calling it again. So inside the same function, I'm just calling as 1. So now let's say 1 is the edge case. So we'll get the answer. That answer is used here. And whatever is the value obtained here, that will be used here. Something like this. This is said to be a recursion. Calling a function inside a function. Okay, so for backtracking, we'll use the recursion only. Using recursion only, we can be able to do a backtracking. Okay, and in this lecture, you can see that they would have taken a station. Let's say its name is Vijayawada. So from there, they'll check what are the other stations they can reach. Let's say I have to reach from one station to the other station. So at what time I can reach? From there, if I have to go to somewhere else, what time it will reach? Okay, so here, let's say they are taking from Vijayawada. So from Vijayawada to, they are trying to reach the Secunderabad. And they have mentioned the timing and the train name also. So they are reaching Secunderabad at 6:15. And then again they are taking the, like they are trying to check is there any other train after 8:15 to reach the place. Okay. And let's say they are taking at 4:25, they are reaching the Renigunda. And from there, they'll try to check is it possible to go to the others. Like after that timing, what are the trains are available, using which they can be able to go to the other one. Okay. If they have already visited, they are not taking into account. If it is not visited, they are taking into account. If it is already visited, they are just ignoring it. Okay, so this is how they're just trying to find the number of stations they can be able to travel, number of places they can be able to travel. Okay, if the let's say there is a train at 22:30, after that there is no other place to visit. So that is said to be the termination condition. Is that clear? Yes. Let's say I have to explore from today morning 12 o'clock to next day morning 12 o'clock, which is like 24 hours. So within this given time, what are the stations I can visit? That is one thing. And next is if there is no other trains are available, I have to do a backtracking and then I have to go and check for the other paths. Or from one path, if all the stations are visited, that is also said to be the stopping point. Is that clear, people?
Yes,
Using which, actually, in this, what are the things we are using? One is the train number, and then the departure time, and the arrival time, and then the which order the stations are arrived. We are just taking these informations. Is that clear? And also, if it is already visited, we are not going to take into account. If that is the case, will it form a cycle? Yes? People, can you hear me?
Yeah.
Yes, then tell me, Ma, can you able to understand this? So, is it possible to find the distance traveled in this? Are we calculating that?
Yes, it's possible.
Means, are we calculating in this? No, right? In this, we have just seen the arrival time, departure time, what train it is, and what are the stations they are visiting. That's it. People, can you all able to understand this?
Yes, ma'am.
Great. All right, people. So next is here, if the station is already visited, are they taking into an account?
Yes, if we visited a station, it should be taken into account so that we don't revisit that station.
Yes. So we have to, let's say if it is already visited, next time we should not repeat it. So they'll just take a account of it. From one station, what are the possibilities are there? Let's say I have visited Renikunda. From there, what are the possibilities are there? Either there will be a visited or there will be a unvisited notes. Is it right, people?
Just one question. So, if I visited, say, some vertex I,
Yeah,
and I
okay.
wanted to visit some other vertex K,
Mm,
and vertex K is not directly related to vertex I, but is
okay.
related to some other vertex M or yeah, whatever. Yeah, exactly.
Mm,
So, if I start with I and wanted to reach K as M I or yeah. So let's say I start with I visit J.
mm.
So then I'll have two options, right? M or K.
Yes. So actually what we'll try to do is, first I'll just try to go from I. I to what are the paths are there? Only one path, that is J. From J, I'll try to visit the adjacent one. Let's say I'm taking the M as the first one. So from M, I'll try to visit. So from M, there is only one path, that is nothing but F. So from F, let's say there are two paths, that is X and Y. So it will try to visit this X. Am I reaching the K now? No. So I have to backtrack and I have to reach F. So from F, is there any other unvisited node are there?
No.
Y is there, right?
Okay, you have Y. Yeah.
Yeah.
Right.
So I have to visit Y. After Y is visited, is there any other unvisited node connected to it?
No, you have explored all of them.
Exactly. So what I'll do, I'll try and come to the F again. So from F, is there any other unvisited vertices here?
No.
So what I'll
You'll
try
come
to do,
to
I'll try to come to the previous step, nothing but M. So from M, is there any other unvisited vertices there?
no. You'll get back to J.
Exactly, it will go to J. So from J, is there any other unvisited vertices there?
Yes, there would be
Yeah,
K,
there
and
is
so
one,
you
that
go
is
to
K. So K has to be visited, so I have visited this. So this
yeah.
is how it works. So
Hmm.
I'll just choose one path. In that path, is it possible to reach the solution? No means I have to go to the its previous step and then I have to check for the other unvisited nodes. So there will be like categories like visited and not visited. Is that clear, people?
Yes, ma'am. So in depth first search, we are allowed to visit one node, one vertex twice, or yeah. So that's possible, right? So here we are visiting a node twice, vertex twice, but we are not exploring the same vertex if it has been visited the first time, right?
Yeah, if it is already visited, we'll not visit that again. But during recursion, it will come to the same point and from there it will try to find the other paths.
This visiting and exploring is not the same thing, right?
Yeah, the same. Actually, what you said is right. Visiting is different, exploring is different. Visiting in the sense
Yes.
of that is the first time I'm trying to enter into that. Exploring means I have already visited. Now I have to check from there, is there any other path?
Yeah. Okay.
Yeah.
Okay.
Okay. Do you have any doubts in this, people? people, please do respond, ma.
No, ma'am.
Can I proceed with the next one?
Yes.
I could see only one response. What happened to others, ma? Yeah, I'm discussing week 11th summary, ma. Not weekly assignment, it's summary. All right, people. Then proceeding further, we'll go ahead with this activity questions. Okay, which of the following statement is true about the depth first search?
It's a recursive procedure. So it uses this recursive algorithm and also uses the idea of backtracking
Yes.
and explores all possible searches at each node before backtracking.
Yeah. So from there, I'll try to explore all the possible nodes. If there is no possibility, then it will go do the backtracking. That is, it is just going to the above one. Okay. Next is a standard depth first search implementation puts each vertex on the graph into two categories, visited and not visited. What is the answer for this?
Yeah, that's true.
Yeah, that is true. Why so? Because whenever I'm visiting any node, so there is from M, mostly there is a possibility that it is visited or not visited. Something like that. Is that clear, people? And here is the next question. A depth first search tree may contain a cycle. Will it contain a cycle?
But like mostly DFSs are used to have directed acyclic graphs, right? So it might not contain cycles.
Yes, exactly. Because let's say in DFS, what are we trying to do? I'm going from I to the other elements only. Is it possible for me to visit I like a cycle here in this graph?
No. I mean, if you're
Exactly.
coming back to I, yeah, because if you then you start back from the initial parent, right? So
Yeah,
there's
it's
no
an initial
point of doing
parent. I'm not going to explore it. Like I'll explore, but I cannot be able to visit it again. Because from X, if it is collected like this, then this is not a DFS one. Because DFS is going in depth further and further. We'll try moving downwards. Okay, so here the answer will be false because it will not contain any cycles. And here is the next question. Some trains can be seen more than once in DFS tree of explored stations in the lecture. Is it true or false?
some trains can be seen more than once. Yes, you can visit it more than once, but you may not explore it more than once. So does seen mean visiting the station? So you can visit the station more than once. That's allowed, right?
Yeah. So what can be the answer here?
Yes, it's true.
True. Okay. Others? Okay. So actually some trains can be seen more than twice in DFS tree of explored stations. Actually, it is possible. So the answer will be true. And here is the next question. In the depth first search technique, if all searches exhaust at one of the nodes, it goes back to which of one? Which of the following nodes? Will it go to the root or will it go to the first node or will it go to the previous node?
It will go nowhere, right? So if it exhausts itself, all the searches in the same nodes, it will just stop there.
Okay. So from X, does it stop?
It says that if all searches exhaust at one of
One
the
of the
node.
node.
Okay.
not in all of the nodes. If it is all of the nodes, then you can say it will just go nowhere. But here at one of the step. So what we'll try to do?
We'll try to explore the other nodes as well.
Yeah, how will you explore it? Will you go to the root or the previous one?
No, I'll go to the previous node.
Yes, we have to just move to its previous node. Can all able to understand this, ma? Why it is just previous node? Please do respond, people. Or people, do you want me to repeat it?
Can you repeat, ma'am?
So here, why it is just previous node? Any idea? Do you want me to repeat that? People, is my question is clear?
Yes, ma'am.
All right. Do you all understood why it is just previous node? Okay. So which of the following information are not available in the DFS tree of explored stations in the lecture? Which is not available in that?
The distance traveled rate.
Yes. Others? Is there any other option is there which is not available in the DFS tree?
I think the first three are easily available. An order of visited stations, because we are also keeping track in which order we are visiting the stations, right?
Yes.
So that's anyway correct.
Okay. Okay, others? Others, please do respond, ma. Or do you want me to repeat any of that people, any of the topic people? All right, people. Here the answer is only distance traveled. So here is the next question. Which of the following situations referring to the terminator branch of a DFS tree of explored stations in the lecture? So what are the termination conditions were there?
So if you have visited all the stations,
Okay.
that would be a termination condition.
Mhm.
And if you have an okay, so if you have an availability of more than one train, so let's see. You have more than one train.
Unavailability or availability? Which, what did you say?
Okay, availability of more than one train.
Okay. If there
Because
is a more than one train is available, so is that considered as a termination condition?
let's see. Okay.
Jim.
Okay. Okay, so if there is an availability of more than one train in a given station,
Mhm.
no, we can still not say that it's a terminating branch, because we can still have trains available in its adjacent vertex that connects it to the terminal station, right?
Okay.
So
Okay. Okay. What are the is there any other option is there to terminate a branch?
no, I don't think so.
Okay, let's say, as I mentioned earlier, so in the train stations, what are we trying to do is we have a duration like 24 hours or 48 hours. So only within that duration, what are the states, what are the train stations can be visited? That also matters, right? So let's say in 48 hours, I have reached around 46 hours. Okay. So after that, if I board a train, of course, minimum it is taking around 3 to 4 hours. So if the time limit is about to get exceed also, I'll stop that. I'll stop the journey, right?
Okay.
So if the exceeds the given time limit to explore the stations, then that is considered as a termination one. So next is availability of more than one train. Let's say, so from F station, there are two trains available to two destinations. So how can you say this is a termination condition? It is still leading a path to one other station, right?
Yes.
So
Yes.
that is not considered as the end point, terminal point. Okay. So next is the unavailability of train at that station. So from X, there is no other station to be explored. Now, this is considered as the termination condition, right?
Yes, that's okay.
So to that branch, it is said to be the termination condition. So these three are the options to terminate a branch of the explored stations. Is that clear, people? Others, please do respond, ma. Okay, fine. So next is they have given a tree here. So we have to find which are the possible longest path. So these are the options, people. So longest path in the sense of longest number of, like maximum number of vertices are visited.
Okay, so A, B, C, E, F, and A, B, C, G, H. So those two would be the options.
Yeah. So what are the options here?
Okay, the first one and the second one.
Yeah. Others, please do respond, ma.
No, madam, I think third one correct. Longest one.
Third one.
The second one, the third one. Yeah, not the second one. There's a yeah, that would be there.
Okay. Is there any other paths?
It's a directed graph, so it's there is any other. And besides, it's acyclic, so it won't be possible. Any other path won't be possible.
Let's say from A, if it moves to this, only two, two vertices are visited. So what we'll try to do is, as of now, it's true. So then it will try to visit from A. So A to B, and from B, it will visit C. So from C, there are of two parts. One is E and F. So A, B, C, E and F. Here, the number of vertices is 5. So we have one more path, that is A to B, B to C. So from C to G and G to H. So this is also 5. So this is the maximum, right? So here the answers can be A, B, C, G, H and A, B, C, E, F. Is that clear, people?
Yes.
I'll be there only, so I can drop you there.
That's right, people. So next is we are trying to create a DFS tree using the mentoring of students. Do you all remember that in the previous lecture we have discussed about mentoring the students, like, so what is the condition to mentor a student?
That the difference between I and J, say the mentor and the mentee should be at least should lie between greater than equal to 10 and less than equal to 20.
Yes, if the range is from 10 to 20, which means let's say the student have scored 84. So if the student range is from 64 to 74, then that how many people who are in this range, they can be mentored by the person who has scored 84. Okay, so that is how we have figured the mentor and mentee, right? So similar way here, let's say we are just randomly taking a 10 cards. So out of which first we'll try to take the card number and then their marks. So let's say, yeah, so these are the card values we have taken. So let's say the card number 8, which is who has scored 74. So first thing is we have to arrange it in the descending order of their marks, which means who has scored the highest will be in the top, and then the remaining marks, it will go in the decreasing order. So then what are we trying to do is, let's say the person who has scored 8, I mean like who has scored 74. So how many people in this max group he can be able to mentor?
So 54 to 64, right?
Yes. So the people who has scored in the range between 54 to 64 can be mentored by the card number 8. So how many are here? So person who has scored 63 can be mentored. Then yes, then
I don't exactly see how many are there. Okay.
yes, 62 is also. Then
Yes.
again there is one more 62. Yeah. Then the next is 57, right? The person who has scored 52 is going beyond this, so we cannot be able to take that. Okay, so these 4 can be mentored by the card number 8. Isn't it, people? Yes, am I audible, people? Am I audible?
Yeah, you are.
Okay.
Audible, madam.
Yeah, okay, people. Fine. So similarly, let's say I'm taking the physics. So physics, the first person who was scored is 88. So how many, I mean, like, what is the mark range he can do a mentoring? What is the mark
60,
range that he can do mentoring?
68 to 78.
Yes, if he has scored, if any people who have scored between the range of 68 to 78 can be mentored by this person. So who are all available here? I mean, like, what are the sequence numbers are there?
88 to 81.
It, okay, let's see Yeah, now it's fine. So it's 17, 13, 24. What's next? What is the next? What is the marks associated with sequence number 24? Is it or 29? Is it?
Okay.
E-
Okay, I think these are the only two people, 17 and 13, and 24 as well.
17 is
That's-
possible? No, but 13 is possible, right? Then
17, no, yeah, 17 is impossible. 13 and 24 are possible.
yes, only these two are possible, right? And how about chemistry? Person who has scored 91. So what is the range?
So 71 and 81.
Yes, 71 to
81.
yeah, 81. So then how many people will be in this range?
We take 3, we can take 2,
Yeah, that is
9,
sequence number 29. Then
we take 3, we
yeah,
take 2,
sequence number 3. Then
2, 9, 12.
yeah, 2 is
That's it.
also and 9
That's it.
and 12. So the card number 1 can mentor these students, like sequence number, I mean card number 29, 3, 2, 9 and 12. Okay, in similar way, so now we have to draw a graph for this. So how it would be? So 8 can be able to mentor 9, 1, 17, 2, and then we have to check. Let's say the person who has scored 72. So he can mentor the students from 62 to 52, right? I mean like at the range of 52 to 62. So we can try to create a graph for this. Could you all please give it a try now? Yeah, people.
So we can start with any one of these, right? So we can start with say 874 or 1781.
Hi, yes. Let's say you're starting with 8. So how the graph
Okay.
will be?
Okay, I think it's so. Would it be better like if we draw the if we have the matrix first and then we draw the graph so that
Yeah,
we
that is
know?
also fine. Yes, I'll just give you 5 minutes of time. Just try to plot it, people. Okay. Okay, so the ranges can be like 10 to 20. So let's say the given mark is around 88. So the person who has scored in the range of 68 to 78 will be the like mentee for that mentor. Okay. Is that clear, Varshit? Alright. So that is the condition you have to follow for all the other steps also. Let's say the person who has scored 72, for them also the same. Okay, great.
Madam, what we need to do actually? Say, I came late actually. I don't understand what.
Alright, actually, so here in this, they have given we have to take the marks. And do you remember in the previous session, we have discussed the mentor and all?
Yes.
Yeah. So let's say so first initially we are taking some random 10 cuts and then we are just trying to arrange the max mark in a descending order, which means who has scored the highest to the lowest.
Yes.
And then we are just taking only their physics mark. Based on that, we are arranging the marks from the high to low. Okay. And similarly,
Yes.
we are doing for the chemistry
Chemistry
also.
also. Yeah.
Like we are arranging from high to the low marks. Then
Yes.
what are we trying to do is we have to take their card number and their marks. So by this way, they are just creating these things. Okay. So after
Okay.
this, what we have to do is we have to create a DFS for this. That is, let's say the person with the sequence number 8. So whom he can be able to mentor. That is the mark range of 10 to 20 is
10 to
his range,
20.
right? So
Okay.
if he has scored 91, then he can mentor the students who are all scored from 71 to 81. So if the
Understood.
person lies between these range, that people can be like the person who has scored 91 can be able to mentor
Mentor.
these people.
Okay.
It is like that. Is that clear?
Yeah.
Yeah.
So now we told some matrix or something like that. That's why I'm asking. So what we need to do?
Okay. So let's say the person who has scored 8. So he can mentor
So for the
people.
max,
Yeah, for max, I'm just starting here. So
so the
74
max
in the sense
74. So maybe up to 54 to 74.
64.
Okay. 54 to 64.
Yeah, which means this is exceeding the 64 limit.
Y-
So the
Yeah.
sequence number 9 can be
9,
entered.
9, 1, and 17, and that's it.
And this is 57. So 2 is also possible, right?
There is 57. Okay. Okay.
And next is 52, which is exceeding the limit. So this is the range. So then what I can do is, let's say I'm taking 9. So 9 has scored higher in physics, right? So whom he can
Physics.
be able to mentor?
For this sound 50, sorry, 50, 78, 60, 68 to 78.
Yes,
So
68 to
to
70.
78. So then 13,
Yes, 13.
24,
Yeah, 24.
then that's it. Then
Next is
so 13 also,
66, right?
13, yeah, it's
So
64.
29.
That is 64, 66 and 64.
Oh yeah, 66, which is beyond this
Uh,
limit. So only 2.
2,
So then
yes.
what I can do is I can just go ahead with 1. So for 1, whom he can be able to mentor. By this way, you have to create a graph.
Mm.
Could you all try it further, people?
So number 3 and 2, 78 and 71, right?
Yes. 71 to 81 is his range. So those who have scored within that range can be mentored. I'll just give further 3 more minutes, people. Just give it a try, okay?
Only 2 note, right, man?
I didn't get you.
Only 2 note only, right? 78 and 77 only. Right?
No, you have to draw for all, right? Like for 17, for 2, and for 13, 24, for all.
So for one, we have vertices connecting to 29, 3, 12, and besides we have have also edges with 2 and 9 as well.
Yes. This will be the range. So 2 is connected with 8 as well as this one, right? Because 1 and 2 are connected using the chemistry. Isn't it, people?
Yes.
Madam, the video screen maximize.
Yeah, how about now?
That's okay.
Okay.
Completed, madam.
Others, have you all completed? Yes, please do respond.
Yes.
Others, do you want some more time or is it done? Right, ma'am. So this will be the final one. This is the final one, people. So can you see here, like, so for 8, we are just mapping what are all it can be able to mentor, and then how many it can be able to mentor. We are just trying to draw this as this. Okay, now tell me, does this form any cycle here?
I mean, there are various cycles here.
Yes. So by let's say one person can be a mentor in one subject and the other person is a mentor. Let's take example here. A is mentoring B in let's say physics. And there's a possibility B can be a mentor of A in some other subjects like maths or the chemistry. Okay, by this way it forms a cycle here. Is it clear?
Madam, actually, I got doubt. So here, first one, yeah, my max 8 only I took actually. Then physics I took only 9, and chemistry I took only 1. But here
You
more
have to
lines
do
are
for
there.
all. Yeah, because let's say 8. So 8 is mentored for let's say three people. And these three people, like we have to draw for them, like how many subjects they can be a mentor and all.
So every serial number we need to check. So for the you can able
Yes.
to maintain.
Yeah,
Okay.
yeah.
I only selected the first one. So the top score only I took actually. Okay.
Okay, which means you would have got only a less number of vertices, right?
Yes.
So we have to do it for all. Like anybody can be a mentor, right? Okay, how about a person who has scored 42? Will that person be a mentor for that particular subject?
No, it could be a mentee, right?
Yes, he cannot be a mentor because he has scored the least mark. The person who has scored the lowest in that group will never be a mentor. Is that clear, people? Yeah, so now let's move on to this activity question. So as we move from root to one of the ends of the DFS tree of mentoring in the lecture. So the mark obtained by the student irrespective of the subject or in the decreasing order. Is it true or false? So which will be the root for that particular subject?
The person who has got the highest marks, right? The
Yes.
sequence number.
Yeah. Then
Then we move from one end. Okay, we are going through DFS tree. So we are okay. So we are going in decreasing order, right? So we are moving in depth. So we are doing a depth first search. So by which we mean that we'll explore all the options who have scored lesser number than the root to begin with.
hmm.
So that's true.
Okay, others? Okay, let's say 8. So 8 has a mentor named 8 has a mentee numbered 1, right? Is that person scored the higher than 80 person card number 8 or lesser than card number 8?
Has to be lesser.
Okay, in one subject, but here irrespective of subject is mentioned. Actually, he is a mentor in let's say he has scored 91 in chemistry, right? and this 8 has scored only 74 in max. Then is it in a decreasing order?
No, this guy can be mentee for D8.
Exactly. This person can be a
Yes.
mentee for some other person in chemistry. So if it is of same subject, then it is yes. If it is like irrespective of the other subject in the sense of it's not in the decreasing order. And here's the next question. So two adjacent nodes of the DFS tree in the lecture represent the mentoring of student in two different subjects. Is it true or false?
Yes, I guess it's true because 8 mentors 9 in math, and then 9 mentors 13 in physics. 9 can also mentor 1 in chemistry. So this can be at least two different subjects. The adjacent nodes can
Yes. Adjacent node in the sense of 8's adjacent is 1, 1's adjacent is 3. Like 1 has two adjacents, 8 and 3. So 8 is a mentor for 1 and 1 is a mentor of 3. So here two different subjects, isn't it? So in this case, it is true. Is that clear to you all? Or you want me to repeat? All right. So the next thing is assume that the length of the each edge of DFS tree of mentoring problem is 10 units. So what would be the possible maximum length of any branch of DFS tree?
it should be less than 30 units, right? So because we are taking between 10 and 20. So 20 should be the highest one.
So let's say here it is 10, here it is 10, and here it is 10. Then
Okay, yeah, of any branch, okay. So then it should be 30.
because maximum they have asked, right?
The maximum would be 30.
Yeah. So there is a one more possibility that one can mentor for two subjects, physics and chemistry, something like this. So in this case, 20 is the value. But what is the maximum length they have asked? So it would be 30 units. And here's the next question. So which of the following tree can be drawn in order to consider all the nodes of a graph starting from node A by using the depth first search algorithm? Assume that the nodes in the left branch are visited first. Then what would be the answer, people?
Can we see the question? I mean, the tree in the question. Yes, so we start. Sure. So starting
They
from
have
node
mentioned the
A.
starting node is A.
Okay, so if we can start with A and then visit B or D. So let's say we start with B. So I mean, our starting node be A, and then we go to B,
Okay.
and then we explore. We have two options: either we explore F or explore C. So here we'll explore F because left branches are to be visited first. So F is to be visited then after B, and then we backtrack to B again, right? Because we cannot. Okay, we can go to A. We can from F to A.
But A is already visited, right?
Yeah, and A is already visited, so we can't do that. So we can go the other way around. So we can see. So we can go from A to B to C to. Okay, we can follow this A to B to C to G, and then we go to H.
Okay.
Or we can go. This would be another. This would be one branch. The other branch would be A to B to C to G to E. uh, A to B to C to E. We can do. We can visit from C to E.
Okay.
That's so possible.
Mm.
There will be so many possibilities.
Right. Then. Okay. Check with the
Yeah.
options and tell me which are the options are right. Okay. Yeah.
Yeah. Okay.
Option A.
Scroll down the options, please. So the first one seems a viable option. Uh, yes. The okay, this one is also viable option. See, we can. Can you go a bit up in the question?
Option A.
Oh no, the second one is not viable because
Okay.
we are in the loop, right? So we are visiting the vertices twice. So the second one wouldn't be possible.
Yeah, I
So
think. Okay. Yeah. Right. Then how about C?
um, okay, A B C G. Okay, G has E and F. That's possible. This is a possibility.
C is possible.
Okay.
Okay. C. Okay. C,
Okay. How about fourth option?
Not possible.
C to E we can't go because then we are in the same loop
Yes,
again.
yes.
We are visiting things twice, the vertices twice. So that won't be possible.
No, C to E, E to F is possible, right?
Uh, can you go
Me
back
too.
to the question? Is losing track of things.
Okay. Actually, it's
Yeah,
like options are because I have to scroll multiple times.
yeah. Long questions. A, B, C.
B to C.
No, no. If we go from A to C and from E, we cannot go to G, right? We cannot visit G. We have to go to F and then we revisit A again. So that's again going back to the roots. So that won't be a possibility, right? Oh God.
Not
Is
possible.
okay. As B to F.
पॉसिबल नहीं होता.
Okay, how about the fifth option?
CBCGH. What PF? Again, I forgot the graphs.
Yeah, this is the graph.
Okay, so A, B, C, G, H.
Yes,
It's
Nikki.
possible.
Yeah,
Possible.
I could
this
see
is possible.
for
Yeah.
all the options, see people are saying possible.
No, last option is possible and yes, possible.
Yeah,
Okay.
I'm forgetting the. So every
Please
time you
note
see the
down in
option,
book, yeah.
Oh, that's difficult to note down.
क्लोन किया होगा, क्लोन करते ही वो पुराना और मतलब जो उसके पिकअप में होगा वो आ गया होगा, ठीक है लोकल.
Yeah, option C is not possible. You can just check the feedback as well.
Okay.
Okay, yeah, that's it. So now moving ahead. Yeah, so similarly, this is also they have taken the train and then they are just trying to explore using the timing on which day it is possible as well. Okay, let's say is it possible on, let's say we are traveling on Monday. So on Monday, what are the possibilities are there and like which are the stations we can be able to visit within the given timing as well. Okay, let's say if I have to visit on like 24 hours or 30 hours based on that. Okay. Okay, I think the activity question will also be similar to that first. Let's just check. Yeah. So the same station can be seen more than once in DFS tree of explored trains in the lecture. Is it true or false?
Yeah, it can be seen more than once, right?
Yeah, it's true. Then the next question is the DFS tree of explored trains in the lecture gives the information of order in which the trains are seen.
Yes, that's true also.
Yeah, because we will store the data, right? Like, so that only we can be able to justify whether it is visited or not. And next is which of the following situations are referring to terminate a branch of a DFS tree of exploded trains? Terminating condition.
If it exceeds the given time limit and there is unavailability of trains at the station and even the visited stations
Visited trains as well, right?
and visited trains as well, yes.
So here, visited trains exceeding and availability of the train stations. Yeah, so far we have did like a station separately and trains separately. So now we are trying to explore both the train and then the stations. That is like a mutual recursion that we are trying to do. So what we'll try to do is we are trying to do, let's say if I'm taking a station. So from there, what are the trains are there and using which, what are the stations can be visited. So we are going to try a graph for that. Okay. So first let's take a list of it and what day it travels. So generally, if I take a station X, so X, let's say they are starting at 1 o'clock. So they are reaching the station Y at 6 o'clock. So from Y to if I have to go somewhere else, so what is the conditions I'll check? What are the conditions need to be checked?
If it's in the time limit of 24 to 48 hours,
Yes. Then,
right?
yeah, that is
And
one of
this,
the condition. Then,
and if uh,
we have
you
to
want to
reach
search it,
the departure time has to be after this arrival time. Let's say here it is reaching departure time is 6. So the next departure time has to be after 6 o'clock. Let's say it can be 6:30, something like that, or 6:05. It has to be after this. Okay, and let's say we are taking off from 6:05, and then we'll reach here by, let's say it's at 15. That is at 3 o'clock in the noon. So from here, if I have to go to any station, what I'll try to do?
check if the departure time of the next
Exactly,
available
we have to
is
check
after.
that, and then it should not exceed the duration as well. So using which we have to try to create a graph. And one more thing is we have to check on which day it will travel. Let's say here it is Monday. Here also it has to be a Monday, and here also it has to be a Monday. Then only I can travel on the same day, isn't it? Or else if I'm choosing something like Sunday, then all the train has to be available on Sundays. Then only I can use this path. Otherwise, I have to try for the alternative path. Is that clear?
remove forcefully कर दिया
Or do you want me to repeat, people?
कहीं से भी नहीं मिलेगा और मैं नहीं कर रही हूँ क्या बोलूँ
Okay. So the next is we have to understand what is the mutual recursion. What is maybe mutual recursion, people? Any idea? Yeah, it is like
Try to
yes, it's about two objects that are defined in their terms. Let's say if I have to take a station, so from there how it is traversing. The same with the stations as well. Okay. And how it is? Yeah, repeat. Is about to say something, right?
I want to say that it involves just two or more functions. So you try to call each other recursively in a circular pattern, right?
Yes, exactly. That's the same thing. So that forms a circular dependency. So if I have to execute one function out of which it is dependent on the other one. So it's like an interdependent one. So that is what is said to be a mutual recursion. So the N node will be dependent based on like where I'm starting. So based on that, we have to calculate whether where the endpoint has to be. Okay, and how it is. So this is all about here. Is there any other doubt, people? Yeah, and also here so here, if a train has to visit the longest path, then what has to be done? Let's say if it is said to be the longest path in the sense of it will just depend on which station it is starting. Let's say here we are starting from the Bilaspur or Bhubaneswar. So let's take Bhubaneswar here. So from there, what are the like stations are visited, and then what are the trains are visited? Using which only we will be trying to uh, like find the longest path, right? Whether they are taking the same train or they are just taking the different trains. Is it? All right, people. Now we'll proceed with the recursion procedure. So let's take example as a factorial. So this is the procedure of a factorial here. So first, what is recursion? As you mentioned earlier, it is a calling a function inside a function. Let's say I'm just taking a function of 12. So inside which I have to call one more function. So to complete that function, again there will be a function call. So this will be complete. This will be like a function inside a function until the condition fails. So there has to be a base condition for that. Is it, people? So similarly, if the condition is true, then that is a stopping condition. So the recursion stops. So whatever is the value I have obtained here, which is to be applied to the previous step. So here also it uses the stack. Let's say I'm calling the function of 5. So function of 5 is called. If I need to obtain a function of 5 value, I have to call the function of 4. To obtain the value of function of 4, function of 3 has to be called. So let's say here the base condition is 0. So till 0, all the function has to be called. Is that clear, people? So for n is equal to 0, what is the value it is returning it here?
1.
Yes, so here it will return the value as 1. So actually, what is the else part here? It has to be n into factorial of n minus 1, which means it has to be like this, right? 5 into function of 5, 4 into function of 4, 3 into function of 3, 2 into function of 2, 1 into function of 1. So here we have got the answer as 1. So that 1 will be given here. So 1 into 1, what is the value? It's 1. So that is the value we have obtained for function of 2. So 1 into 2 is 2. So 2 is the value we have obtained for function of 3. And for function of 3, it's like 3 into 2, 6. And here, This is how it works. Is that clear, people? Can you able to understand this? Okay, I'll just tell you one more example. Let's say I'm taking function of 5. So for function of 5, what will happen? It will check with this condition. Whether 5 equal to 0? No. So it has to call as 5 into function of 4. So for function of 4, what has to be done? Whether this 4 is equal to 0? Exactly, it's no. So what it has to be done? We have to give it as 4 into function of 3. So for function of 3, what has to be done? Okay, before that, people, do you all know what is factorial? So factorial is nothing but multiplying the values from 5 or n to 1. Let's say the factorial of n. So for which I have to multiply n into n minus 1 into n minus 2. Until I reach 1, I have to multiply all the values. Let's say if I'm taking 6. So I have to multiply 6 into 5 into 4 multiplied with 3, which is to be multiplied with 2, which is to be multiplied with 1. So this is how we can be able to find the 6 factorial. Is that clear? Okay. So similarly, here also I'm trying to do the process. If I have to find a 6 factorial, it has to be 6 into, this is 5 factorial, right? So that is what is written as 5 factorial. If I have to find 5 factorial, it is 5 into 4 factorial. I can simplify like this, right? Because 4 into 3 into 2 into 1 is nothing but 4 factorial. So similar way we are doing it here. Is that clear?
Yes, ma'am.
So then 4 factorial can be written as 4 into 3 factorial and goes on. So the same way here I have to write as 3 into factorial of 2. So for factorial of 2, it has to be 2 into factorial of 1. And for factorial of 1, 1 into factorial of 0. So what does n equal to 0 means?
1.
Yeah, so here I have got the value as 1. So 1 into 1, what is the value?
1.
That is the value we have obtained for factorial of 1. Then 1 into 2, it is 2. That is the value of factorial of 2. 2 into 3, 6. That is the answer of factorial of 3. 6 into 4, 24 is the factorial of 4. And 24 into 5? Yes.
Madam, why again we are going reverse, madam, actually?
Because to find the factorial of 5, first I have to go in depth. So by this way, I'm just storing in the stack. First I'm calling function of f5. So to get the answer of function of 5, I have to do f5 into function of 4. So to find the
So
function of 4,
every
I
time,
have to take...
the else condition will execute, right? So that's what you are telling.
Yes. Yeah. Because this is said to be the base condition. So once the base condition is true, the recursion stops. So whatever is the value I'm obtaining, I'll just try to substitute and I'll try to get the final solution. So here it will be like 3 into factorial of 2 and here 2 into factorial of 1, for which 1 into factorial of 0, something like this. So once I receive the answer for this, I'll just substitute and this will be taken out. And then I'll just get the answer and this will be substituted for here. And 3 2s are 6. 6 is the value for function of 3, which will be substituted here. And this 24 is the value substituted for function of 4. And the whole is the answer of, like 120 is the answer of this function of 5, which will be substituted here. So at last, I'm just taking the value. That's it. Is that clear?
In the pseudocode, how it's going, madam? Actually, we understand the first if block, and we can
So
understand
if
else block
condition I
also.
have just given as n is equal to 0. If it is n equal to 0, if the condition is satisfied, return 1. Otherwise, we have to, let's say, if the value is 5. So is 5 is equal to 0?
No,
So if condition will not work, it will go to the else part. So
else
else part,
part.
what has to
Okay,
be done? 5 into function of
4
5
factorial.
minus 1. Yeah, 4. So
4
for again, now what is the n value? The function is called again for the factorial of 4. So is
So
4
this
is
function
equal to
again, it's
0?
going to the above function.
Yes, exactly.
Okay.
So again, it will call
Okay.
as 4 into function of 3. Is 3
3
equal to
factorial.
0?
Okay. So one particular time it will be satisfied. 0 equal to 0.
Yes. At that
Then
time, it will return the value as 1, which is taken here, which is substituted here, and it will evaluate, and at last we'll find the final solution.
okay. Then after that, what is happening? Return 1 is coming. Then after that, what is
So it
happening?
will just, so for function of 0, we have got the value as 1. So 1 into 1 is?
So every area again the return value will now we are
Yes.
in the
So
if
here
function.
the return value.
Now we are in if condition. The last one is executed because 0 equal to 0. Then return value is 1. Then
Yes.
it won't go else part, right?
Yeah, after that, the whole recursion stops. That's why it will start to go to the previous steps because we are taking it in a stack, right? So first one is solved. So it will go to the next step, that is function of 2. So once this function of 2 is solved, it will go to its previous step as function of 3. If function of 3 is solved, that will be taken out and its value is given here, and function of 4 will be solved. Once this is also solved, it will go to the function of 5. So that is what is happening in this case. Is it clear?
Okay, madam.
एक क्वेश्चन ये है कि प्रोजेक्ट स्ट्रक्चर को सही से समझा पा रहा है वो फिर
Do you want some time to understand this or shall we proceed further, people?
उसको मन में 5 मिल ही नहीं रहा था एक क्वेश्चन में ये
Alright, I'll just give you 2 minutes of time. Just understand this one, people. Then we'll proceed further. Okay. Yes, ma. Have you all understood this? All right, people. Any doubt in that?
Can you do for n equal to 1, madam? So we can understand simple one. So n
Yeah,
equal to
sure.
1. So we step by step the pseudocode, so we'll understand. Because
Okay.
the reduction is I can understand, but how again the substitution and multiplying I cannot able to understand how it's happening.
Okay. Let's say the n value is 1. So what is the n value here? Function of n. What is the n value here?
1.
Is 1 is equal to 0?
No. False. Then else
So what
statement.
it will do? It will go to the else part. So
Else
else part,
statement.
what has to be done?
1 into 0 factorial.
Yes.
0 factorial.
So what is 0 factorial value?
0 factorial 0 only. 0 factorial 1. Okay.
What is 1
0 factorial
factorial?
1. 1 factorial also 1 only.
Yeah. 2 factorial is 2.
2.
3 factorial is
6.
yeah. Something like this, right? It goes on.
Yes.
So
Yeah.
now
Yeah.
factorial of 0. So what is the n value here?
Here 1 only.
The function is called for 0, right? So what is the n value then?
Then 1. Return 1.
Yeah, n is 0. So if 0 equal to 0, it has to return 1.
Return 1.
Yeah, here for function of 0, 1 is returned.
Okay.
So 1 into 1, what is the value?
1.
So which is the answer of factorial of 1? Is it right?
Yeah.
Okay, let's say I'm calling function of 2. So for function of 2, what will happen?
So it will go.
2 into function of 1, right?
Yeah.
So what is the value I have obtained for function of 1?
1.
So 2 into 1,
2.
that is the answer of function of 2. So let's say I'm calling function of 3. Then
No, but this function where it takes, madam, in pseudocode again 2 into f1 where it is there. It is in the else condition only, right?
yes, initially let's say function of 2 is there. Is 2 equal to 0?
So not equal to
No.
0.
So what it has to do? It has to go to the else part. Else part
Yes,
is
correct.
2 into function of 1. So for function of 1, is 1 equal to 0?
No.
So what it has to do? 1 into function of 0.
0.
So what is function of 0 value?
1.
Yeah. So 1 is taken here, which is the returned value. So far we are still stopping with this function calls, right? So we are taking this value and we are using it for the further purposes. So previously we have did like 2 into function of 1, right?
This explanation I can understand, but from the pseudocode because once you see if you cross the n, if it is n is not equal to 0, then we will the else statement. Then the else statement finished, then it will be end, right?
Yeah, it is a n for function of 1. So for function of 1, it has returned with 1. So now for
Okay.
function of 1 we have called. Has it returned any value to that?
How it will be called here in this procedure? So we are
Here we have
it's a
called, right?
factorial position is n.
Yes. Still the function call is remaining, right? We haven't returned any value to that function call. So for that, we are just, whatever the value we have obtained here, we are taking it to the previous step. That is to this step. Is it clear?
Previous steps means
So how this is, so
yeah,
here.
from within the else statement. Within the else statement you're telling.
Yeah, in else statement, one function call is pending, right? It will just go to the pending function call because it has written the value for the present function call. But previously, there are 2 more function calls are remaining, right?
Okay, so the else statement only is executing one by one, reductioning the numbers, and once the final number coming, it's referring the above one.
Yes, it will go to the previous steps and it will evaluate that.
Okay.
So
Very
whatever
too
the value
complex,
I'm
man, this one.
obtaining here,
Yeah.
yeah, based on that, it will just go to the previous step and there it will evaluate again.
Okay.
Been able to understand this now?
The way
That's why
they
I
explained
said,
it,
let's say if
yeah,
it
I
is,
understood. But pseudocode
okay.
only, when seeing the how the steps going back, that only we're not able to understand.
So this is the function call, right? That's why. There is a
So
function
you
call
now
inside a function
else
call.
now, for example, madam, else we are coming. We here there is no return value, right? Here there is no return value. So return is here itself is mentioned. So
Yes.
return is coming. Then this return again it will take it to the factorial of n.
Yeah.
Okay, that is only just very confusing because here again now it's going to the above only. Okay, maybe we need to
Because inside
remember.
a function, we have a function call.
Okay,
Again,
understood.
inside a function, there will be a function call. It is like that.
It's like loop. So for
Yeah.
every like that. Okay, got it.
Yeah, so this is what we'll say it as a recursion. Inside a function,
Okay.
there is a function call, the same function.
Recursion.
And
Okay,
again, inside this, again, I'm calling this same function call.
got it, madam. Thank you.
Okay, similarly, they can do for finding the sum of array, sum of elements in an array. So if the array is empty, it has to return 0. Otherwise, first of n. What is first of n?
First
What is
element
meant
of the
by
list.
how
The
about
list,
rest?
right?
How about rest?
Okay, excluding the first element, all the rest. The
Then
list,
how about init?
excluding the last element.
Yes, last of which?
Only the last element.
Exactly. So in this, what they are trying to do is we have to add all the elements in the list. So they are taking the first of, let's say the array containing 12, 26, 10, 6, and 7, like this. So in this first of one is 12. So it will be like 12 plus. Again, the function of is called for the rest of list, which means now the list containing 26, 10, 6, and 7. Is it clear?
Okay, now we'll say return of this function of this thing plus the list sum of rest of the function of this thing.
Yeah. That is then
So that
26 plus the remaining elements nothing but 10, 6, and
10,
7.
6, and 7.
Yes. Then what will happen?
Yeah, then we'll go for the next iteration, right? So we'll have
Like
first
10
of this,
plus.
yeah, 10 plus the the rest of the function of 10 of 6, 7. So it will give me 6 and 7. This
Okay.
would give me 6 plus f of 7. So,
Here,
and then we'll
7
have
plus
7 plus
function of empty.
empty list. Yeah.
So for empty list, it has to return 0. Can others, can you say what will be the next steps and all? Here it has written 0. What has to be the next value?
It would be 7, right?
Yes. So the 7 will be returned here. Then
13 would be returned in f of 6, 6 and 7, and recursively through we'll follow the process to 12 plus the first step.
yeah, here I'll get it as 13. Other than Sandeepan, can others say what will happen after this step? For function of 6 and 7, I have got the answer is 13. Then
23 will be will take into the 26 plus function of 23. Again,
yes,
the
so
23
here,
plus 26 will be added.
yeah, 49 will be taken here. Good. Other than these two people, can others say what will be the next step? Yeah, so here it will take it as 61, which is the answer for the function of overall function call, right? Is this clear, people?
Madam, here I have one basic doubt here. So here the first
Yes.
statement, the written first L plus list sum of rest L. So the rest means, okay, in this rest, the last it will be rest in last, right? Rest of L, right? Okay.
Yes.
Rest of L means it is a more elements, right? How we can add actually now the program I can understand adding, but logically that statement plus means for example one element is there. First of L I have like assume I will take 5, and rest of
Yeah,
things I
okay.
have assume 1, 2, 3, 4, 5. How I can add
No,
actually?
the first element will be taken, right?
Yeah.
Let's say
Then
the array containing the element is 1, 2, 3, 4, 5. So here first of means 1 is taken. So 1
yeah.
plus function
One,
of rest of L, which means leaving 1, what are the array elements are there? That is taken into count. Isn't it? That is the
here
usage of rest of, right?
yeah, but here list sum rest L.
List sum is the name of the function.
Okay, this is a function. Okay. Okay, got it, madam. Got it. Okay.
Fine. Others, do you have any other doubt? Can anyone say what is the purpose of this list sum to? How this will work?
It recursively calls the functions, right?
Yes. Then, what is the purpose of this code?
To sum up the elements of the given list.
Yes. So previously in the first 1 to n, this is like n to 1. Is that clear, people?
It's clear. That
Yeah.
one is a
Do you want to
forward
give
direction,
it?
it's a reverse direction, but both are
Exactly.
will be same only, right? Output will be same.
Yeah, output will be same, correct. Okay, any doubts so far, people? Yeah, so choose the correct statement about recursion from the given options. So recursion in the sense of it is a process in which the function calls itself until the termination. Is it true or false?
It's true. Yeah.
Okay. So
True, madam.
what are the options are correct, people? Just tell me what are the options are correct.
The first one is correct. The second one is wrong because iterative processes have more time complexity.
Okay.
Requires yeah, it requires a base case, right, and an inductive step to
Yes.
complete the process.
Yes, perfect. So by this way, we can be able to travel through the 3 easier as well.
Yeah, right.
Okay. So these 3 are the answers. And here we have to find the
That,
summation of n
madam,
natural number.
sorry to interrupt, but the third option, what
Yeah.
is it? I don't understand. So
It requires a base case. So base case in the sense of, let's say, we are giving that array of length is 0, then stop. So this is what is the base condition. So
okay.
inductive step in the sense of the like a recursion step. Like I'm just giving like x
Function of
plus
function.
some
Okay.
of function
Yeah.
call inside a function. That is the inductive step.
Complete the process. Okay.
Yeah. So there should be a base case. If there is no base case, the stack will keep on filling it, right? So that leads to a stack overflow condition.
Okay. But the fourth one, what is a traversal easier one?
Traversal in the sense of so far we are using the tree, right?
Mm-hmm.
So using the recursion, let's say I have to take a right and left elements. So I have to travel to left. So it has 2 children. Again, I have to travel to its left child. So again, travel to its left side. So by this way, we can be able to travel till the depth, right?
Yeah.
So it makes the
Mm.
tree traversal easier.
Okay. Okay. Got it.
Okay. And here is the next question. So we have to find the sum of n natural numbers. So factorial, what we did? If the n value is equal to 0 means it has to return what?
1.
Okay, otherwise,
You go for n into f of n minus 1.
yes, n into function of n minus 1. Here you have to do the same for sum of n natural numbers. So what has to be done?
You have to sum, then instead of star, you have to put the plus, return and
Okay.
plus. Yes.
Okay, and is
And
there
into
any
n
other
minus 1.
condition to be stated? Is there any other condition to be changed? If n equal to 0, what it has to return?
And
When
equal to
equal to
0,
0,
then
it returns 0 itself.
Yes, which is
Otherwise, one
nothing but
addition will be there. Yeah, 0.
yeah. So it has to return the same n itself, right?
right.
Okay. So now here they have given if the x is not equal to 0, what has to be done? Yes, which of the options is right? If the n is not equal to 0 means.
Second
Summation
one.
of
Sorry,
the
third,
Second one.
second option.
Second one.
Second option.
yes, x plus summation of x minus 1. Perfect. And here we have yeah, so here what this L is? What is mean by init of L?
Okay, so init of L will count when we take the first n minus 1 element, and then again doing init means taking n minus 2 elements.
So removing the last 2 elements.
Yes.
Yeah, so yes,
So if I take n element, then 2 elements are, sorry,
Last 2 elements.
yes, these 2 elements are removed, then it will take this element. Here they have given that, what is the L initially? It is
yes,
like 1 to
1 to
n.
n.
Okay, so now let's say I'm taking 1 to 5. 1, 2, 3, 4, 5. And let's say initially I'm taking L as 1, 2, 3, 4. Okay, now first it will take 5, then 5 and 4 are eliminated. Then which value is taken?
1, 2, 3.
In this last element is what?
3.
Yeah, after that, 2 elements are eliminated. Then it will take 1. Okay, then the list will become an empty one. Now in this case, what will happen? Initially it will take 4. After that,
1, 2, 3 is there. 3, 5, 6. So 6 plus 4 would be 10.
no, leave this
Oh,
separately, take this separately.
okay. Okay, so
Now
the
for
list,
this L, what will be the values it will take?
So 1, 2 only it will take.
Yes, 3 and 4 gets deleted.
Yeah.
Then it will take 2. After that,
After that, nothing.
list becomes an empty. Okay. So here I have taken 5 elements. I have added all the
Odd
odd
numbers.
odd
values, right?
integers.
Odd numbers.
Yeah, here I have taken till 4. Then here,
Even numbers.
yes. So what can be the value options here?
So
Yes, 2 and
second and third.
3rd. Yes, that's. Is that clear, people? Okay, any doubts so far?
Last one, how 2 answer will come. Actually, any maybe it will be even or even number sum or odd number sum only, right?
Yeah, but whether they mention what the n value is, whether they mention that.
Oh, n value is not mentioned. So that's reason,
Yes.
okay, yes, they mentioned the n is a even number. Okay, got it.
Yeah, based on whatever is the n value, it will just do that.
Got it,
Is
madam.
that clear to you all?
Clear.
Okay. All right, people. Do you have any doubt so far?
For me, no, madam.
Okay. Others? All right, people. If you have no doubts, you can leave. Thank you.
Thank you, madam.